Good afternoon, everyone, and welcome to today's webinar on methane detection and LiDAR UAS payloads, brought to you by NEI and Microdrones. The agenda for today is fairly straightforward. We'll start with an introduction. First, our speakers, a little bit about NEI and overall imaging solutions, followed by another portion on microdrones themselves, the MD Mapper, MD LiDAR, and MD Detector solutions, including a success story from the field, to conclude with question and answers submitted through the Q&A portion of your GoToWebinar control panel. Presenting today is myself, Chad Hicks with NEI, the Imaging Solutions Team Lead. I'm also joined by Matt Rosenbaum from Microdrones, the U.S. Southern Region Sales Manager. And our moderator today is Janine Hightower with NEI, our MGIS Sales Team Lead. So a little history or chronology of NEI, how did we got to where we were, or where we are today, I should say. Starting all the way back in 1988, our founder, Charlie Pochet, purchased and started the firm from John Chance. We soon became one of the first and original 5 Trimble mapping and GIS dealers in the United States. Fast forward all the way to 2015, where we became the first worldwide mapping and GIS dealer of the year, and continued that trend into 2016 and 17 to cap it all off with our brand new facility now in 2017, located in Lafayette, Louisiana. So NEI does a lot more than most people are aware of. These next few slides are going to talk a little bit about that. One of our first and probably most prominent solutions are the survey and construction line of products, as well as mapping and GIS. Again, one of the few authorized Trimble mapping and GIS dealers in the United States. Our territory includes Louisiana, Georgia, Mississippi, Alabama, Arkansas, and Florida. We're also one of the advanced technology dealers with things like UAS that we're going to talk about today, as well as land mobile systems, the MX2, MX7, and now MX9 mobile imaging systems. We're also a Trimble Marine dealer, authorized again in those same states, offering some of the most advanced marine navigation solutions available. NEI manufacturing includes both cables and cases. We have a unique facility in place to create and customize cables and cases for just about any need you may have. Fleet management solutions as well. NEI is one of the authorized resellers of the Trimble Field Service Management Solution, which includes the Trimble Locate to Protect device management system. Also, rentals and used equipment. Try it before you buy it with 1 week free rental policy. Check out other used equipment on our eBay store for rock bottom deals on gently used, pre-loved total stations, data collectors, Pelican cases, and much, much more. Finally, field supplies, from stakes to paint safety gear, we've got you covered. All backed and supported by our award-winning training and support department. We've got the technical training and educational services you'll need to acquire, maintain, and optimize your skills, offering 3 different types of trainings, from one-day classes, on-site training, as well as online training. So for more information about any of these other products and services offered by NEI, feel free to contact us via our website or call us toll-free at 1-800-949-1446. NEI, we've got your back every step of the way. So today we're talking about imaging solutions. These next few slides are going to discuss just what are imaging solutions. The imaging portfolio, as it stands for us, includes a variety of solutions, including indoor, land mobile, as well as unmanned aircraft solutions. A complete mix of both software and hardware, as you see across your screen. The indoor solutions include The Trimble Indoor Mobile Mapping System, affectionately known as TIMS, comprised of a mobile scanning unit from Faro and an Applinix IMU, along with the imaging system. The land mobile systems now include both the MX2, MX7, and the brand new MX9, a complete field-to-finish mobile mapping solution combining state-of-the-art advanced hardware with intuitive field software, a reliable, efficient office software workflow. And most of all, what we're going to talk about today, unmanned aircraft systems, both fixed-wing and rotary. Our fixed-wing solutions are now from Bel Air, including the UX5, UX5 HP, UX5 AG or multispectral, and the brand new UX11. We're also going to talk about specifically today Microdrones MD solutions. Again, the MD mapper, MD LiDAR, and MD detector. So, before we get started, a poll question. Our first poll question is about just what UAS solutions are out there. If you would take just a moment and respond, are you currently using a UAS solution today? All right, looks like we just about got all of the votes in, and we'll go ahead and share these results. So it looks like the majority are using a rotary aircraft solution, and then a lot of you, 43%, are not yet using a solution today. So we'll take this information and continue forward with our presentation. Next, we're going to turn it over to Matt Rosenbaum, who's going to talk about microdrones.
I'm glad everybody was able to make it today. It looks like we got quite a big crowd. I'll go and just kind of do a brief overview of who I am. My name's, like I said, my name is Matt Rosenbaum. There's my big ugly mug there. I'm currently a resident of Atlanta, Georgia. I started with Microdrones in October of last year after working with one of our resellers for about a year and a half. I'm a graduate of the University of Louisiana. I've worked in the surveying and mapping and engineering side of things for the last 5 years of my life since graduating college. With a relatively new to UAS, I'm passionate about it. I've got about 50 hours flight time with the Microdrones MD4-1000. I'm a Part 107 pilot, and I really enjoy working for this company. To kind of talk a little bit about Microdrones and who we are, we're one of the oldest commercial UAV manufacturers. We've been around for about 15 years now. It all started with the drone in a view back in the day, and we've now become one of the forefront leaders in providing a full solution mapping solutions. Not only just making the drone, but also integrating new payloads into those drones, and also the software. We develop all of our software and everything in-house, and it's a full turnkey solution to provide you with survey-grade data for your unmanned aircraft. We have offices in the U.S. in Rome, New York, on the old Griffiths Air Force Base, which is one of 6 FAA test sites here in the U.S. For unmanned aircraft, as well as our solutions. Our MD Solutions is located here in Montreal, in North America, in Montreal, and all our drones are manufactured in Germany. So they manufacture their airframes in Germany and send them over to Montreal, where they integrate all the new and latest and greatest payloads into our existing airframes. We've got almost 100 employees now, and some of the brightest minds in the industry working for us, and it's really a great company to work for, and we're always looking to partner with new companies and stay on the forefront, leading edge of technology. Kind of a little bit going into our airframes. This right here is the MD4-1000, which we'll be spending most of our time on. What does German engineering really mean? Well, the MD4-1000 has been flying for about 10 years now. So as new technology comes about, we don't build a whole new airframe around our new payloads. We integrate new technology into the existing airframe to keep you flying for many years. The airframe is meant to grow with your company. As new technology comes out, you can add a new portion to your business. There's about 7 or 8 different payloads now available for the MD4-1000. It's our workhorse of our UASs. It can fly in extreme conditions, rain up to a 45-degree angle. So if you're finishing a mission, you don't need to worry about the drone getting caught up in the rain. You know, you can finish that mission and land it. You want to make sure you keep your payload out of the elements. It flies in a plus formation, which is another unique feature to our drones. It's a little bit harder to accomplish, but it keeps the drone more stable in flight versus your X-copters that you see more frequently out there. As well as our motors are rated for 10,000 hours, so we don't really have a maintenance protocol for our airframe. You always want to check and make sure no chip props or anything. But as for the motors, we haven't had anybody come close to reaching 10,000 hours yet. Hopefully one day somebody will, so we can continue to show that to our customers and everything of how quality and everything our products are. This is our lineup of UASs. It all started with the one on the left, MD200. It's strictly a nadir mapping UAS. It's got about a 25-minute flight time. It'll map with a 20-megapixel camera, as well as a thermal camera and a MicaSense multispectral. The one in the middle is our latest drone that was introduced last year. It's our heavy lifter, the MD4-3000. It can carry a payload up to 13 pounds. One of the unique features about it is it's shaped like an airfoil. So when it's actually flying forward, it produces lift to put less strain on the motors and increase the flight time. And then the one on the right is our MD4-1000, which is our workhorse. It's meant to do everything for your company, from mapping to methane gas inspection to structural inspections and everything. So with that being said, we're going to start with our first topic of the day, the MD LiDAR 1000. What LiDAR is, it stands for light detection and ranging. And when flying airborne LiDAR, that consists of 3 things: an INS, inertial navigation system, paired with a high precision GPS, as well as the laser sensor. So when you have the IMU or the INS paired with the GPS, it stands for it turns to be direct georeferencing. So what direct georeferencing is, I guess the easiest way to explain it is in photogrammetry. When you're flying, it knows the roll, pitch, and yaw, plus the post-process positioning, the northing, easting, and elevation of where the camera was. So as it's taking that image, before you actually process the data, you know exactly where each pixel is orientated on the ground. So this doesn't change for flying LiDAR. It's actually required in order to fly LiDAR. You need a high precision IMU. So when you're using the IMU, it knows exactly where the points are on the ground from the laser without having to use the ground control or anything to tie that to the ground. It knows the roll, pitch, and yaw, or the omega phi kappa, of how the sensor was tilted, and then the survey grade post-process positioning of the drone at that moment in time, and it marries everything together. One of the biggest proponents of why LiDAR is so intriguing to people is in photogrammetry. When you take an image and you're flying over trees, it assumes the top of the trees as the bare earth. So you're not able to get that surface model from flying it. So with the LiDAR, there's the ability to have multiple returns. The MD LiDAR 1000 is no different. It has up to 3 returns. Typically, it's usually the top of the trees that you can see here. Maybe another return on a lower branch, and then the third return being the ground in most cases. So you're able to not only get the returns from the laser on the trees and have those built into your model, but also get the bare earth model, which most surveyors are looking to get. Also, when flying, another benefit to LiDAR is the intensity of returns. So as you can see on the left, the high contrast from the Griffiths runway, you can see the striping in the all the lanes and everything on the runway. This helps when classifying the point cloud. So the more intense the return, it's able to be able to, the softwares are usually able to pick out the different areas from it and classify that data, such as power lines and roads and edge of curb and all that good stuff. I guess that might be a little bit more intense getting the edge of curve, but you understand, like it's able to classify the power poles and all that good stuff in the software with the types of returns you get from the LiDAR. So getting into the actual drone itself, our solution is the MD LiDAR 1000. It consists of an MD4 1000 plus the SICK LiDAR, which is manufactured in Germany, the sensor, paired with the Trimble APX15 IMU, and then an industrial camera for point cloud colorization. So this payload flies on the same MD4 1000 that you could be flying the methane gas detector or the a base camera for photogrammetry. It's a simple installation. It's a quick turn of the wrist. That's interlockings to lock onto the drone as a simple 45-degree turn of the wrist under the drone. It's powered by the drone, and it also includes a carrying case. The software that's included with it is MD Cockpit for mission planning, as well as POSPAC UAV, which is the Trimble Planix program to get your exterior orientation or your direct georeferencing data from the drone, as well as the MD LiDAR processing software. So what we provide with this unit is everything up to the georeference point cloud. So from there, you can take the LAS file that we produce from our MD LiDAR software into your software suite of your choice for your point cloud classification and actually producing the deliverable. It's an easy end-to-end workflow, I guess I kind of just went through. It's a simple mission planning, and I'll do a demo of the MD Cockpit here in a second. So inputting your point density based on what you're looking to get in your deliverable. It's a fully automated mission. Once you take off, you throw it into waypoint mode, and the drone takes care of the flight for you. Georeferencing is done in POSPAC UAV, and then the final point cloud is produced in the MD LiDAR app. So this is kind of a screenshot of MD Cockpit, what a mission would look like. And before I go through it, I'll kind of explain what these waypoints are in the mission and the actual mission that was created. So if you see waypoint 1 and 3, those are actually alignment waypoints. And what that means is before you fly and after you fly your survey mission or your polygon that you just created, you need to make an alignment waypoint to excite the IMU. So essentially the drone flies up to waypoint 1, flies in the same direction for 10 seconds, stops, does a 180 and flies back. And once you do that, you're allowed, it shows you on the screen that your IMU is aligned and you're ready to start scanning. You can input your flight height, your drone speed, and the overlap all in here in order to achieve the point density you're looking for, and also gives you the flight plan results in the flight. So with that being said, I'll open up MD Cockpit here on PC so you guys can see it. So this is my neighborhood here, and I'll go in and build a mission for you guys so you can see what I'm doing. So first thing I would do when I hop in here is I can go into, and I'm going to select which payload I'm flying. So in this case, I'm going to be flying the MD LiDAR. I select that. I come in here and I want to draw a survey polygon. So I'm going to go around this portion of the neighborhood. And I'm going to go in here and I'm going to tell it which sensor I'm flying. So I'm flying the SICK LiDAR. So I can change my hatch angle in order to optimize my flight. What I'm doing here is I'm going to keep it at 60% overlap, and I'll fly it at 50 meters. And in order to, I'll need to make my alignment waypoint. So I'll put one here, alignment waypoint. And then I'll drag one in front. So in there, they're going to fly in the same direction at that speed. And in here, I can also see how much area my polygon was. So it's in meters right now. So it's 74,000 square meters. So probably around 35 acres or so. I might be completely off, but I think that's right. And another thing we just released for the drone. See, this mission would be done. I would actually go in and add a land waypoint right here at my house. After I'd be done here, I could go and save the mission, but also we just released, if you see up here, this is called the terrain following. So in order to keep a constant GSD, or when you're flying photogrammetry, or a constant height over the terrain, it's going to utilize the land, and the drone will actually follow the terrain and stay 50 meters over the ground the entire time to keep that same swath width from your drone, from the laser, as well as keep the the same point density because you'll be staying at the same height over the terrain throughout the day. It utilizes Google Maps in this case. We can actually also utilize the more robust PC version of MD Cockpit, and if you needed to upload an existing DWG, we can actually follow that. Like if you have new elevations of a site, if you're working, you can follow that terrain if you needed to be that precise as well. So from here, we would just go in and save the mission. I'd save it as demo NEI and be good to go and save it. And then once we get in the field, we can upload that to the drone and actually move on. So these are some screenshots. So when you can see when you're actually flying the drone, like I said, everything's fully integrated into our airframe and into our software. So the first thing it's going to do when you actually power on the drone is it's going to collect data on the ground. And you can see on the left screenshot that it's collecting its initial data. And once it's done, it'll give you a check mark. And it's also letting you know the payload is ready. So you can see on the right here as well as the GNSS and the SPS is good to go. You got a green check mark, but the APX hasn't been aligned, so you haven't flown that alignment waypoint yet. So once you fly the alignment waypoint, you can see over here on the right, the drone will actually talk back to the MD cockpit and let you know that the APX is aligned and your mission is ready to start. This is all doing it on its own in the during the flight, so you know that the data that you're about to collect is going to be quality data and there's not going to be any hiccups. You didn't have your IMU wasn't working properly or whatnot. So it's kind of all fail safes before you actually fly to make you feel good while you're flying the mission that you're going to get data. This is the screenshot of the MD LiDAR processing software. So after you get your exterior orientation from POSPAC, your lat long and altitude, or your northing, easting, and elevation, and then your exterior orientation of how your drone was orientated for while you're scanning your Omega Phi Kappa, you bring that into our MD LiDAR processing software, where we marry that with the LAS file from the flight from the drone. In the configuration tab, you're going to set your bore side angles, and we'll get into that here in a second, as well as your output coordinate system that you like your data to be in. And it marries everything together and produces your georeference point cloud, all done in software that we've produced. The absolute accuracy of the system is about 6 centimeters in the X, Y, and Z. This is all done on testing when we were on Griffiths Air Force Base. We had 56 GCPs set out with using a total station by a professional surveyor in New York that we have flown many times, and we're really conservative with our accuracy. This was flown at a 40 meters at 3 meters a second to get that point density. But a typical, you're usually seeing a 1/10.5 to 2/10 on all your Z elevations for the most part, and a lot of times it can actually be much tighter depending on the speed and the point density you got. This is a sample data set from a site we fly, farm site we fly a lot in Ontario, just to kind of give you an idea what the data would look like from this LiDAR. And then I keep talking about point density. This is a graph that's actually inside the MD LiDAR software to kind of give you an idea for planning your flight, what kind of point density you're looking to achieve, what flight speed you'll have to fly at, and height. So typically our sweet spot that we found is about 40 meters at 4 meters a second. It gives 60 to 70 points per square meter. It also can cover the most area efficiently. It's got about a 25-minute flight time with our MD-41000 with the LiDAR. We usually get up to about 45 minutes with the photogrammetry payloads, but this one's the LiDAR's a little bit heavier. So it's meant to make the 1000 a little bit more versatile. So the the flight time is diminished a little bit on this, but you still can cover about 50 acres of flight with the MD LiDAR 1000. The bore site calibration, what I mentioned earlier. So in-house, we write our own algorithms for calculating the bore site, the calibration. So what the bore site calibration is the angles from the GNSS to the angles and the distances from the GNSS to the IMU. So without a properly calibrated laser or LiDAR system, you can see you might have a lot of noise. Like in the top photo, you'll have multiple lines, and you can't actually get a very tight data. So without calibrating your sensor you would get data like at the top. So after you do actually have the proper boresat calibration, you can get all your lines married together and everything looks clean, is not noisy. So many other manufacturers have to send their sensors back to the manufacturer that actually makes the sensor, the laser sensor, to get these boresat calibrations, where we have the knowledge and the wherewithal to do this in-house. And if you have a problem, you come to Microdrones versus having to go to 7 or 8 different hands in the fire. Every payload is sent with the MD LiDAR calibration report, as you see here. You get your lever arms and your mounting angles and your boresat angles, and this is all inputted into the MD LiDAR processing software. And you don't have to continue to edit every now and then. It saves it in there. So when you actually bring in the data from the drone, you're able to continue to process your software in that streamlined workflow and get quality data sets every time. So I think Chad has a poll question here. If you want to add that before we get into the CH4.
All right. Thank you, Matt. Also, just want to remind everyone, if you do have any questions that come up at any time along the way, feel free to go ahead and go to your GoToWebinar control panel and enter the questions. Right now, we're going to launch just one more poll here. This one is, how likely are you to employ an unmanned airborne LiDAR? All right, we'll go ahead and close that out and share the results with everyone. It looks like about, 35% are likely, 29% very likely, 18% are definitely interested. Thanks everyone for participating, and we'll turn it back to you, Matt.
Good deal. Well, now we'll get into the M-Detector 1000 CH4. This is also one of our latest payloads. We introduced it at Commercial UAV last October. Who should consider using the M-Detector 1000 CH4? Professionals or companies responsible for inspecting gas, methane infrastructure, tank inspections, landfill emission monitorings, gas well testings, as well as natural gas line surveys. What we'll get into in this presentation is the explanation of the M-Detector 1000 CH4, the hardware software overview, as well as the methane sensor, the integration module, and then both the apps that go along with the same MD Cockpit app we just went over, as well as the M-Detector Viewer app, which allows you to see the data in the field. So what's included in the M-Detector CH4? So obviously you're going to be flying it under the same drone, the MD4 1000. The payload is the PerGam LMM Gen 2 sensor. The integration module includes the sensor as well as the stabilized nadir mount that you see down here in the bottom right, and an FPV camera that you can see what you're monitoring in real time from the drone, as well as the HD video link for viewing that sensor. Software included is obviously the MD Cockpit Android app, and then the M-Detector Viewer app, which I just spoke about, that allows you to see the data in the field for post-flight. So some specs on the LMM, the Laser Methane Mini gas sensor. It's specifically manufactured to sense methane gas. It's an extremely sensitive sensor from 1 to 50,000 parts per million per meter, and it measures at 10 hertz, so 10 readings a second, and has an operating distance of about 100 feet. So when you're flying over a pipeline, typically 50 to 75 feet over the pipeline is kind of the wheelhouse that we stay in. The operating temperature range from 1 to 122 degrees Fahrenheit. And it uses an infrared laser in order to sense the gas. So how this works is if there's methane gas in the area, the infrared sensor is partially absorbed by the methane, and the sensor calculates an algorithm to figure out how many parts per million of gas was in the area, was able to absorb the laser, and it shows you that real time on the tablet and from the sensor. It also has a green laser light for showing where the sensor is actually orientated at the moment. Some advantages of the LMM: it's got fast response and high sensitivity, and it detects at a distance, so you don't have to get boots on the ground in order to go in areas that might be dangerous. It's obviously excellent for detecting methane gas. It's lightweight, and it does a self-startup in the beginning, so no calibration required before the flight. The integration module components that are included So the nadir mount ensures that the sensor is going to be pointing down. It also keeps the vibration down to a minimum. Also an interface for the flight controller to read the sensors and store those on the drone. The drone actually provides power to the sensor. So other manufacturers have tried to use this sensor with their drone, and they weren't able to fully integrate it like we have. So they'll have to have an external battery powering the sensor and an external data collector to collect the data, the readings from the laser methane sensor. So you get more weight, and which reduces the flight time. So typically with this, most of our missions are usually around 30 minutes with this, depending on what you're flying. But we can still it's roughly the same weight as the camera, so you can get up to that 35 to 40 minute flight times with this sensor as well. And it also has like I said, the FPV camera, so you can see what you're sensing when you're flying. The MD Cockpit Android app. So this is actually what you're going to see when you're flying the drone. The drone plots the readings behind it as it's moving forward, as well as lets you know how many parts per million gas you're actually sensing at that moment. So you can see here the little donuts it's leaving behind. It's usually colored depending on what it's sensing, and then or how intense the readings are from the methane. The 11 right here is how many parts per million of methane gas is actually in the area, and then clear is just letting you know that the sensor is clear and functioning properly. So once you land the drone, you get a reading. So this was flown over a well site. You would get the same type of readout if you're flying over pipeline or whatnot, but this was flown in a grid formation. So what you can see is this is down. Once you land the drone, you download the thin flight data or the TFD from the drone and via Bluetooth onto the tablet in our MD Detector Viewer app. From here, you'll be able to see the different readings it was able to get while it was flying. So as you can see here, the yellow donuts are anything from 100 to 500 parts per million, and the red donuts are anything 500 parts per million and above. So the clear was anything from 0 to 100 parts per million of gas. So what you can do in the app is actually change those tolerances to narrow down exactly where the leak is coming from, to narrow down. So from here, we can go to the next slide. And from here, they changed anything from 0 to 200 parts per million, they're going to leave as clear. Anything from 200 to 500 parts per million would be yellow, and anything 500 and greater would be red. So you can see that the gas started, the intensity changed, so you can see exactly where the most intense methane leak is coming from, or methane deposit is coming from. And then you change it one more time from 0 to 250 is clear, 250 and up is to 2000 is a yellow, and anything greater than 2000 is red, to actually find exactly where those leaks are coming from. So you can actually make a repair in the field. And once you're done with the app in the field, you can actually download all that data as a CSV and export it out and use it in your GIS software that you use, such as Trimble Business Center or any other software. In the CSV, it gives you the lat long and the altitude of the drone, as well as the intensity of the methane leak or methane reading it got in that area. So just to kind of go back over the workflow, during the flight, you get the live telemetry with the live readings of the sensor, as well as the monitor set up to view the FPV camera from the drone. Post-flight, once you land, you download the TFD from the drone, view the data in the field on the MD Detector Viewer app, and then export it out as a CSV for the people in the office to manipulate the data. This is the testing site that we actually developed this payload at. As you can see, leaks, we had manufactured leaks at 1, 2, and 3, the black, and the drone found all the manufactured leaks. We also found a leak that wasn't planned. And this does get false positives from a reflectivity, so just to be mindful, sometimes if you're flying over a building, you might get a false reading from the drone, and we documented in those areas from 1 and 2 where we had false readings. So the great thing about this sensor is it isn't a one-trick pony. It's not strictly stuck on the drone. So once you actually finish your flight and you you can get, say you flew a pipeline and you found a couple of readings of leaks from the sensor in certain areas. You can actually use the tablet to go back in those areas where they were found and take the methane sensor off of the drone and use it on a pistol grip how it's normally used. So typically we're using this methane gas, the sensor, it's used walking, it's used by walking a pipeline or walking, an area and sweeping it with the pistol grip. It can be hours upon hours of walking in dangerous locations. So the drone can actually be deployed quickly and used in the air to find leaks over broad distances and then brought back down and used traditionally like it was to actually find exactly where those leaks were coming from, and then get a repair team out in the field to repair those areas. Some advantages of the MD integration of the LMM. We record all the data on the drone, so there's no external data collector needed. It also reduces weight and keeps the flight time high. The sensor is powered by the drone, like I stated, with the battery from the drone, so there's no external battery to add weight, and you get live feedback from the Android app. And then exporting the results out is easy as done on the tablet as well. Who we consider the M-Detector CH4, clients are people that are looking to add another solution to their existing airframe. So say you're flying pipelines with the DG all the time, and you wanted to be able to add another service to your customers. You can throw the M-Detector CH4 simply on the drone and produce another deliverable for your customer that they're probably already doing in another way with walking these pipelines or driving it with a four-wheeler. You can improve and standardize maintenance services on your pipelines or on your well sites. It's great for natural disasters such as hurricanes. You can deploy it quickly. It improves the workflow, time spent in the field. You can reduce the amount of people that is needed to inspect these areas in these harsh conditions. Time is money, and you're definitely going to save a lot of time by flying it with this sensor versus actually driving or walking pipelines in dangerous conditions. And it reduces the environmental impact of the ground-based methods. So you might not have to walk in areas that, is sensitive to people disturbing an area that doesn't need to be disturbed, such as, for wildlife and whatnot. You don't have to worry about that when you're flying above it all. So it's kind of just a mission statement to do. It just allows you to be more efficient with this versus traditional methods of walking and walking in dangerous areas. So with that being said, we have a real-world user, one of our high-end users here in the United States at Raven Air, Mark Sakich and Ivan Hirschberger are here. They're going to kind of talk about their company. They're located in the northeastern part of the United States and have the M-Detector CH4 as well as a mapping package that they utilize.
Like Chad and Matt were saying, we're a company located in northwest Pennsylvania, but we cover the entire state. Actually, we're branching out. We're going to go, we haven't really set how far we won't go, but we're a sister company to Two Track Drilling, which is Ivan and his brother and their father started this business probably 15 to 20 years ago, and they decided that they liked the technology and wanted to branch out, and with the contacts they have in the gas industry, thought that partnering with Microdrones, that this was an avenue we wanted to pursue. I was in the gas industry for almost 20 years with the utility and worked with Ivan for a long time, and when he started this venture, brought me on to oversee and project manage what we're working on and used our contacts, and we've done 3 or 4 demo flights actually with some local utilities and found the M-Detector to be very accurate. Weather has been our biggest in northern West Pennsylvania, our biggest issue, but the companies that we work with are very excited, like it. and we're working through some of their standards and operating procedures to allow use of drones. But we find that this is a real exciting area to be in. We found that last flight we took, we were actually able to overlay our flight with local companies' survey, and found that we were very close in our numbers of ppm that we found flying that they had with walking traditional with an FI, for instance. So we're really looking forward to this process. And
well, no, Mark said it well. This is an exciting new venture for us, and I think it's a good complement to our place in the industry. We've been working in gas distribution and utility infrastructure for quite a few years, and yeah, this is something our customers are excited about. And one of the things I did want to point out is two of our demo flights just happened to be incredibly windy days that were almost too windy to fly in, and the performance of the airframe that Microdrones had was incredibly impressive, just how it hangs in there. And what was really impressive to us and to the customer was the ability of that sensor to still be able to pick up the leaks that they had despite the weather challenges. So that certainly was a real life test to what this system can do.
Well, great. I really appreciate that, and that's it's great that you guys are able to fly in those conditions, and we look forward to your guys' success. And thanks for coming on and sharing your story about the M detector that you guys are using in the field.
Absolutely. Thanks for having us.
No problem.
yeah, thank you very much.
Well, that concludes our presentation, my presentation. I appreciate everybody coming on and joining us. Chad, I guess you can take it away from here.
All right. Thank you, Matt. So before we close out, one more final poll question. How likely are you to employ an unmanned airborne methane gas detection system? All right. Thank you, everyone, for your vote. We'll take a look at the results here. So it looks like the winner is likely at 26%, followed by a tie for definitely, and then some not at all. All right. So question and answer time. If there's anything that's been covered today that you do have a question about, now would be the time to go ahead and go to your GoToWebinar control panel and enter that question so we can answer it as these come in. One question that we see already coming in, Matt, is are the payload options for the MD-1000 all interchangeable?
Yes, absolutely. So we can take switching from flying a photogrammetry payload to a LiDAR to a methane gas sensor to the multi-axis gimbal. It usually takes a couple minutes in the field. You might have to change a wire, unplug a wire, and plug another one in depending on which payload you're flying. But it's usually done within 5 minutes. Once you get the hang of it, it's really simple. So, yep, they're all from the 1000. You have 7 or 8 different payloads you can change fairly quickly.
Okay, great. Looks like one more question here. Can all the data be processed using the Trimble Business Center and UAS Master software workflow?
Yes. So when flying the LiDAR, you're going to actually produce the point cloud in from the MD LiDAR processing app. That'll produce your LAS file. Then you can simply drag that and drop into Trimble Business Center. Or if you're flying the MD-4000 for like the mapping packages such as the DG or the base mapper, you can absolutely process those in UAS Master. It's my choice for actually processing photogrammetry data, as well as here in the next month or so, we're going to be releasing, be able to produce a JXL file from the MD4-1000, which will utilize the same workflow that the UX5 does, which a lot of people are used to in Trimble Business Center.
You mentioned the Android app, but is there an iOS option?
Not currently. There isn't an iOS option. We utilize everything's done on the Android side of things. I don't know if there's one coming up in the future, but I think the reason they've kind of stuck with Android since the beginning, and probably will continue to do so in the future. We recommend the Samsung Galaxy Tab S2. It's manufactured to fit into our mounts that work with our RC, as well as it's a really robust tablet, and it's great for powering all of our devices that need to be able to talk to the drone from it.
What is the difference in overall processing time between LiDAR and photogrammetry data?
So when flying LiDAR, it's actually processing it. You can actually have that processed, within 15 minutes after you land. So the only thing you're actually processing is the exterior orientation from the drone. So that's bringing the T04 file from the drone into POSPAC, marrying that with your base station data that you have set up on the ground. That is that gathers your corrections. Once you get that post-process exterior orientation, you marry that to the point cloud that was produced in that's not corrected from the LiDAR, and you can have a point cloud, georeference point cloud, in about 15 minutes after you land. Whereas with photogrammetry, it all depends on how big of a site you're flying. So if you have 500 images, it depends on how many images you have, plus the size of your computer. So you can fly 50 acres in one flight with the LiDAR and have a point cloud in 15 minutes after you land, whereas you might take 50 acres with the base mapper package might have 300 images or 200 images that could take 3 or 4 hours to process in your post-processing software. Now when flying the DG, that's one of the benefits of it. You can use less side lap and overlap and have less images and more accurate images, more higher resolution images, and less of them because of utilizing the APX15 IMU. So your processing time with 50 acres might be, an hour versus the 3 hours that it could take with the more images from the base mapper.
All right, thanks, Matt. Looks like one final question. What is the ultimate flight time with the LiDAR payload?
The flight time with Indy LiDAR 1000 is about 25 minutes. So we can cover about 50 acres with that flight at 4 meters a second at 40 meters, which is our optimal speed and height for point density on the ground.
Okay, great. Well, it looks like that's just about all of the questions. I really appreciate everyone attending today. As I mentioned earlier, if you do have any other questions or you would like any more information about anything that we've discussed today, feel free to contact us either online at neigps.com or call us directly toll-free at 1-800-949-1446. On behalf of Matt Rosenbaum with Microdrones, Janine Hightower, and myself with NEI, thank everyone for attending.